Come on, guys. You know the consequences. Maybe you won't return. Please, stay here.
We must go. Stay calm, Borja. I have flown a plane before.
We need to profit this opportunity. Everything's gonna be alright.
You must understand it. It's for the progress of humanity.
1956. First time humans travel into space. Science, technology, and engineering have improved so much that they make the exploration of the universe possible. People have dreamed about it for thousands of years. They have been contemplating the universe from down here in order to figure out what was happening out there and how it was. So, in order to understand the laws of that universe and also some phenomena that occur on the Earth, they have made a lot of researches and studies about it. Now, we're going to reach it and find a new world so that we can see our planet Earth from another point of view.
See you soon, Borja.
It will be a short time for you, but I think that it will take a long time for me.
Wait a minute, how takes a rocket off into space?
A space rocket is a type of machine that, using a combustion engine, produces the kinetic energy needed for the expansion of the gases, which are released through a propellant tube. It consists of a structure, a jet propulsion engine, and a payload. The operating principle of the rocket engine is based on the Newton's third law, which states that when one body exerts a force on a second body, the second body simultaneously exerts a force equal in magnitude and opposite in direction on the first body. Imagine a closed chamber where combustion gas excites. Gas burning will produce pressure in all directions. If we make an opening in the chamber where the gases can escape through, there will be an imbalance. The pressure exerted on top of the chamber will produce thrust, because there won't be any pressure on the bottom of the chamber, where the aperture has been done. In this way, the rocket will move upwards, due to the pressure exerted by the combustion gases in the combustion chamber of the engine. The magnitude of thrust produced depends on the mass and velocity of the gases exhausted through the aperture. Then, the higher the temperature of expelled gas, the greater the thrust, and it will be necessary to cool the motor.
Ground control to Major Tom. Lock your Soyuz hatch.
One of our purposes taking off into space is to study how the condition of microgravity also called zero gravity, affects humans and other living organisms. We want to know if life for humans outside the Earth is possible, which means if we are able to live in the zero gravity condition, in a giant engine over the space, in another planet, or even in a satellite in the future.
For humans, the exposure to zero gravity condition for a long period of time may cause muscular illness, heart diseases, loss in bones, etc. Those are the speculations that we make, and surely they will become present after being on space for a long period of time. There is also an engine which is being developed that could contribute to create the same gravity boost as we have on Earth.
We are the first scientists studying the response of human beings under low gravity. Of course, we have achieved what people have been trying for a lot of years. And now, with those experimental measures, we can start studying and developing new engines that will make possible the advance and the improvement of lots of machines and engines. These are not only used in specific areas of investigation, but also in daily life, and what's more, they will help cure some diseases.